Awesome, so now we got one last missing piece in this app, which is the spatial audio, the fireworks audio that plays when the fireworks is on. So this one, we wanted this to be a spatial audio, meaning it's spatially aware. So when you move your hands far away, the fireworks would sound a bit softer, and when you move it closer, it would sound louder, just like in the real world. So let's get started adding the spatial audio in. So for this to work, first we need some fireworks audio file. I downloaded mine from online. I'll add the link in the description with this video, or if you want to download a different audio file, you can do the same. But once you've downloaded that and saved it somewhere on your desktop, what you can do is go here in the project navigator, and then you can go here and say add files to the project. So for me, I've saved it in my download section, this guy here, fireworks. So I'm just gonna add that, and then make sure you select the Vision Loki Fireworks, the project target where you want to add it to, and then click finish. And now hopefully you should have the fireworks audio in place. I'm just gonna drag this inside this project folder. So now it's in here, and now you can preview it here as well. Great. So this is the firework audio that we wanna play when the firework is on. And we want this to be a spatial audio. So on a high level, the way we're gonna do this is we're gonna attach this audio to the entity itself, the fireworks entity, and make sure we configure it to be a spatial audio. That way the audio will play as part of the fireworks and it will be spatial in nature. Now, how do we do that? For that, it's a very simple method. So if I go here in the make closure, you can see here we have a fireworks entity, right? This is of type entity. And now if I do fireworks entity dot play, now you can see every single entity, it comes with a play audio function, and this prepares and plays a new audio playback instant on this entity. So what we need to pass here is an audio resource, which essentially contains a link to the audio file here. And then also what we can do is essentially configure the spatial audio component. This is the component that configures the spatial rendering of sounds, and we can make sure this entity is configured to play spatial audio this way. So that's on a high level what we're gonna do, but we're gonna do it a bit neater and not here. So what I'm gonna do is collapse this, and I'm gonna create an extension on the entity. So extension entity, and I'm going to create a new method. Let's call this, say, func play fireworks. Essentially, this function should play the fireworks on the entity and return as an audio playback controller, which will help us monitor whether the fireworks audio is playing or not. And you'll see why that will be useful later. But in here, we're going to do two things. Like I mentioned before, first, we need the audio resource file for the fireworks file. So this audio resource will essentially be the link to this fireworks audio here. And then what we'll do next is we'll configure entity to play spatial audio. And then finally, number 3, we will play this audio resource file on the entity. So play audio resource on entity. This way, we'll have the fireworks audio being played as a spatial audio on the entity itself. Great, so let's do these next. So here, I'm gonna say create a new audio file resource, and I'm gonna use this guy here, named, and this would be the name of our audio file that we just added to the project. It's called fireworks, right? So fireworks, and the extension, if you go to Finder here, and you can see this is an MP3 file. So make sure that reflects here. So do .mp3, and now we're going to assign this to, say, a variable called audio resource. And now we get an error saying this is an async call. So let's mark this with await, and we need to also make sure that this function that's calling this should be an async as well, or else it won't work. Now finally, the call can throw, so we need to wrap this inside a do catch statement, or we can do it like so: guard let try, and if that exists, great. If it doesn't, do a fatal error saying error loading audio. Great, so now we got the audio resource here, which links to this fireworks mp3 file. Now next up, what we'll do is we'll make sure this entity is configured to play a spatial audio. So what we can do is self, this is the entity, and then we can do the spatial audio, this guy here, like we've seen before. This is the component that configures the spatial rendering of sound from this entity. And here, what we'll do is we'll add a new spatial audio component here. So spatial audio component. Great, it's simple as that. That's how you configure this entity to play spatial audio. Obviously, you can configure various parameters of this if you want, but I'm not going to go over that now. I'm just going to go with the default parameters that we get. And now finally, what we can do is say entity, which is self dot play audio. Again, this prepares and plays a new audio instance on this entity. And you can see here, this returns an audio playback controller, right? That's what we can use to monitor if the audio is being currently played or not. So we're going to get that as well. So what I'm going to do is play audio, pass in this audio resource file. So audio resource, and then I'm going to say let audio controller that this function returns. I'm going to assign it here. And now finally, I'll just return audio controller. Awesome. So that's the play fireworks function. And what it simply does is it plays the fireworks audio on the entity, and then it returns returns us the audio playback controller, which will help us monitor whether the audio is playing or not. And next up, what we're going to do is add one more function, and this we'll call it stop fireworks. And what this will essentially do is stop the fireworks audio. For this is pretty simple. Entity comes with a function called stop all audio. Again, this stops playback for all audio on this entity. So any audio that the entity is playing, it will stop it. That's all we need. Simple as that. Great. So we got these two helper functions as extensions on the entity. Now we can use them in our app. So it's one to play the fireworks audio and one to stop the fireworks. So let's do that next. So here what we're going to do is in our reality view, again, we got the make closure here, and all the hands closed to open action appears in this update closure where we update the 3D scene based on different state events. And in this case, the state we're interested in is hands open. When this changes to closed or open, we want to show the fireworks and play the audio, and vice versa. So here we first retrieve the fireworks, that's good, and then we update the fireworks spawn position, and then we also show hide sphere here, right? So this is where we want to add the play audio function. So what we want to do here is if the hands is open, we make sure the fireworks is shown by setting the fireworks is enabled to true, and if it's closed, we set it to false, i.e. the fireworks is invisible. So what we're going to do is first we're going to check if the hands is open. So if his hands open, if that's true, what we're going to do is use the fireworks entity. This is the fireworks entity, and then play the fireworks audio on that. So play fireworks. This essentially plays the fireworks on this entity as a spatial audio. And this says async call in a function that does not support concurrency. And that's because this update closure, this is not asynchronous in nature, while the make closure is. For this to work, what we need to do is essentially wrap this inside a task. So what I'm going to do is wrap this entire thing, just copy that, delete that, and do task, and then paste it inside. And now finally, we'll just prefix this with await. Awesome, so that's inside an asynchronous context now, and that should work. So if hands open, we'll play the fireworks, and the audio controller that we get from this, what we're going to do is we're going to store that in a state variable here. So what we're going to do is call this state var audio controller. This would be an audio playback controller, and this would again be an optional. And here what we'll do is we'll assign that here. So audio controller equals await fireworks play fireworks. It's simple here. We're playing the fireworks, and that returns an audio playback controller, and we assign it to this guy here, which we'll store in our view because we'll be using that later. And this guy here essentially lets you monitor whether the audio is being played or not. Great, so that's working. Great, so now if hands is open, play the audio and store the audio controller in the state audio controller, this guy here. And then if it's not open, if it's closed, what we do is we do fireworks.stop fireworks. This would stop all the firework audio. Awesome, so simple as that. And now if you try and play, I won't do it locally here, but if you try and play, you will notice there's a glitching sound, right? The fireworks audio works when you open and close the hands, but there's a lot of glitch and it's very jittery. And that's because whenever this is hands open variable changes, which happens very quickly, right? Your hand gestures are being detected very quickly. So whenever this guy gets triggered, this guy plays the audio firework again and again, and that happens very quickly, and hence the jitter. So for this to work smoothly, what you need to do is only play the fireworks if there is no audio playing already. And that's what we can monitor using this audio controller. And that's why we're using it here. Great, so what we want to do is if hands open and fireworks is not playing, then we play the fireworks, else we ignore it. So for that, I'm going to create a new helper function here. So just below load fireworks, call this function is audio playing. This should return a bool, right? True if the audio is playing, false if it's not currently playing. So for this, we're going to use the audio controller here. Again, this guy here. So this is an optional state variable, and we set that when we first play the audio fireworks here, audio controller. So what we're going to do is check if the audio controller is set in place, because it's an optional, remember. And again, the audio controller is set here when we play the fireworks. So first, let's check if the audio controller is set. So we're going to do guard let audio controller equals audio controller. If it's set, great. If it's not set, we're going to return false, i.e. the audio is not playing because the audio controller is not set. It's only set when we first play the audio. Great, so we got the audio controller here unwrapped if it's already set. Now if it's set, what we're going to do is we're going to check if the audio is playing or not. Audio controller dot is playing. This is a Boolean value that indicates whether playback is currently active. This is what tells us whether the audio and the entity is currently being played or not. So if it is playing, we will return true. But if it's not playing, we'll return false. Because we're not returning this, so just add a return before this guy here. Great, awesome. So all this function will do is it will return true or false based on whether the audio is playing or not. Now let's use this. So here back in the reality views update function, This is the guy here where we play the audio and disable it. So here what we're going to do is just before we do all this logic, the playing and stopping, we're going to do if is audio playing, i.e. if the audio is currently playing, simply return, i.e. we will skip all this. Awesome. So now just before we build and run, this looks a bit ugly, the code, so I'm just going to clean this up a bit. So here essentially what we're doing is we are first making the fireworks entity, the 3D bit, visible or invisible based on if the hands are open or not. And then we are playing the audio or stopping the audio, again, based on whether the hands are open or not. So we can essentially put both these into one function, right? We don't need to do this separately. And what I'm going to do is simply inside the play fireworks function, this guy here, the extension to the entity, we're going to not just play the audio, but we'll also make sure the audio entity is visible or not. So here what we can do is just before playing the audio, we will make fireworks visible, make entity visible. So for that, it's pretty simple. You can just do self, which is the entity, and dot is enabled. This makes the entity visible or not. So I'm going to set this to true. Great. So this will make the fireworks entity visible and it will then play the audio. So that's the play fireworks function. And similarly in the stop fireworks function, we're going to do the same thing. Just before stopping the audio, we will simply do self dot is enabled and set that to false. So this would hide the fireworks and stop all audio. So now we got these extensions to the entity. Play fireworks, it would play the fireworks and make the fireworks entity visible. And then stop fireworks, it would hide the fireworks and stop the fireworks audio. Great. So let's use this now. So back here now, first what we're going to do is we're going to get rid of this because we don't need to show or hide the hands anymore. Why? Because this play fireworks function does that already. It both plays the audio and makes the fireworks visible. Similarly, the stop fireworks both hides the fireworks entity and stops the audio. So we don't need to worry about that now. So also, this is a little bit of bug here. So what we're going to do is we don't want to do the check here. We only want to do the check after we know it's in hands open, right? So here what we're going to do is if hands is open, then we check if the audio is playing. So is audio playing? If that is true, we simply return. Great, so that should fix everything now. So it's simple now. In the update closure, we retrieve the fireworks, set the pawn position for the fireworks at the hand, near the middle finger, and then we play or stop the fireworks based on whether the hands are open. If the hands are open, we first check if the fireworks is already playing. If it is, we return. But if it is not playing, we play the fireworks and assign the playback controller to this audio controller object, which is used elsewhere to check if the audio is currently playing. And then if the hands are not open, i.e. the hands are closed, we stop the fireworks, which both stops the audio and hides the firework. And then finally, we add the updated fireworks to the scene. Great, so now our app is done. And now if you click play and run, we should see everything work. Let's try that out. Awesome, so we got a lot done in this app, right? In this project. Now I'm just going to summarize the key points. So the first thing that we learned was for any kind of ARKit based tracking, like hand tracking in this case, we need to run the experience in an immersive space in mixed mode. So that's what we've done here in the app starting point. And then we created a hand tracking class, which essentially makes use of the hand tracking provider and the ARKit session to extract hand tracking data that comes with ARKit. So the hand tracking data essentially is contained in the handcur object, which essentially gives us all the skeletal joints in our hands. And what we do is first we gather the spawn position, which is the middle finger joint, and we use that as the position to spawn the fireworks from. Then we also designed a custom gesture, is hands open. Again, based on joint data that we get from hand anchor, what we do is essentially calculate the distance between the little finger's tip and the index finger's tip and use a threshold to crudely determine whether the hands are open or not. So using the hand skeletal and joint data, we both determine the position we want to spawn the fireworks from, and we design a custom hand gesture to detect if it's closed or open. And in this class, essentially the process hand updates function loops through all the hand anchor updates we get in real time and triggers this callback, which passes whether the hands are open or not, and the spawn position as a three-dimensional vector. And this class is used back in the content view. So in the content view, again, what we have here in the body is a reality view. We first load the fireworks and display the fireworks in the reality view. And now if I collapse the reality view, again, what we do here is essentially before the reality view is displayed, we run the hand tracking session using the hand tracking model, the class that we just created, and then we process the hand anchor updates in real time. We add another asynchronous task for that, and we update the spawn position and the is hands open, these state variables, these two guys here, in real time. Every time we get a new update, these guys gets updated. And whenever these guys gets updated, the update closure in reality view, which modifies the 3D scene in the reality view, gets called, and that essentially updates the position and the play stop state of the fireworks. Great, so that's how our entire experience functions essentially. Great, so that was the project. And we learned a lot in this project. We learned about hand tracking first and foremost, how we can track hands with precision using ARKit and hand tracking provider. And then we learned about assigning custom gesture using the data we get to detect whether the hands were closed or open. And we also learned about spatial audio. We learned about particle effects. We learned about reality view and how we can display and update a 3D scene using reality view in SwiftUI. And then we also briefly touched on Reality Composer Pro to design our 3D scene. So we learned a lot, and hopefully this gave you a good idea of how the visionOS ecosystem works. Now, if you want more in-depth, beginner-friendly courses on developing for visionOS, do check out my site, realityuni.com. I've got a bunch of courses going from the very basics to the advanced if you want to make use of that.